Hello everyone, I'm Chris McIntosh. I help teach the statistics courses. We're going to go over your week 1 computer assignment. Some objectives for this assignment is we're going to learn how to set up and manage a data set using Excel. We're going to learn how data should be arranged on a spreadsheet so data can be analyzed in Excel or another program. We're going to reinforce the concepts of population, sample, parameter, and statistic. We're going to reinforce levels of measurement, nominal, ordinal, interval, and ratio. We're going to identify qualitative and quantitative variables. We're going to identify continuous and categorical variables. We're going to prepare a data file to use for the next assignment. And we're going to learn what an Excel table is. So what is a data set? A data set is related data arranged in rows and columns suitable for analysis. Usually observations are in rows. That might be participants or some other thing that you're looking at. And attributes are in columns, and those are the things about the individuals that you're interested in analyzing. Ideally, you should include a code book that explains what each variable is in the data set. And to illustrate this, we're going to look at a big data set from the National Health and Nutrition Examination Study, or the NHANES. So I'm going to open up a browser window and show you guys how I get here, because it's not that hard to find. So if we type in NHANES data, and you'll see the National Health and Nutrition Examination Survey comes up at the top, and we're going to go down here to this About the Data section. And NHANES has been going on for a long time. You'll see we've got down here to 2000, but we're going to go to this first square under continuous NHANES, and it says NHANES 8/2021 to 8/2023. And you'll see there's a section here that says data, documentation, and codebooks. And we're going to go to demographics data. And you don't have to go here if you don't want to, but I wanted to show you what a real research data set looks like. Okay, so we do have the data file column, and this is in a data format called XPT. It's used in a statistical software called SAS, SAS. We're not going to open that up directly, but I did want to show you guys the doc file, and this is the code book for the data set. All right, and as you can see, there are these different codes here, and we can actually click on these codes here in the code book, and you can see the name. You'll see there's a variable name, which is very short, and then they spell out what each variable is, and we can even get more information by clicking on a particular variable, and you'll see we can see the SEQN is the respondent sequence number. Basically, it's an ID for each individual in the study, and then we have variable names and value descriptions. And I'm going to look at another one that is categorical, in this gender, RIAGENDR. And you'll see that if we look at this gender variable, it gives us these codes. So ones are males and twos are females. And so this is a nice example of a code book to tell us what the data look like inside of a data set. So I went ahead and opened up the data set in another program and give you guys a screenshot of what this would look like. So you'll see that these variables are in the same order in the column headings that they were in our code book, SEQN, SDD, SRVYR. and that just makes it easy to navigate the code book and the data set when you have things in the same order. And there's our example of the codes used for gender. So I gave you guys a data set. You want to download and open this data set called HEVI 2024 CKD data set. And I will get this open. And that was a different workbook I had it opened up. All right, so once you get this open, then we'll go to the next section. Pause this if you need a second. All right, I did want to mention to you guys, so this data set came with the HEVI text, some additional course resources. We're not going to use this for much analysis. You'll notice that on the tabs on the bottom for the different sheets, you know, there's an intro, lab 1, lab 2, and we're not going to go through these sheets as Dr. HEVI had created them, but if you're new to Excel, it would not be a bad idea to just read through these things, and you always learn something new, so it's you know there for you to look at as you're able to. But I just wanted to point out that we're not going to use these for analyses other than these first couple weeks for some examples. But yeah, read through these lab sheets. It's educational, non-assignment, but for your own knowledge if you want to. Okay, so we're going to read through the Excel intro sheet. I do think there was some nice concepts in there that we can look at. We're going to see the Excel formulas, which we're not going to use much of, but if you're not familiar with formulas, it's good to just get a little familiar with how that works in Excel. And so we're going to do some data management principles. So in here, if you go to the Excel intro sheet, which is the first one in the list, and if things are shifted over in yours, sometimes if you make the window a little bigger, that helps, and then you can go back and forth using these arrows for the tabs for the sheets. And so if we just skim through this, a couple key points here. As Dr. HEVI notes, Excel is rarely the easiest choice for statistical software calculations. There are a number of inferential tests that you can do in Excel. I never use Excel for statistics just because, you know, if you have your numbers formatted a little different, there's just things with missing data and things to keep track of, and statistical software makes that a lot easier. And we're going to look at some statistical software later in the semester, in some upcoming weeks. But Excel is everywhere, and it's good to know how to use it because it's a great general tool. And sometimes you might need to format some data a certain way, and Excel's probably going to be the tool that you have access to. So this was a good place to start. So HEVI does explain what Excel functions are. If you click inside this sum box here that she listed out, you'll see there's a formula there. It's adding these together. I'm not going to go through formulas, so if you're not familiar, definitely read through this sheet. We're not going to do much with Excel formulas in this course this semester, but it's good to understand them, how they work. And Dr. HEVI goes through some examples of doing some different calculations, and then there's some other things there. So I want to see if she talked about populations and samples. Okay, I think that was it for the introduction sheet. Okay, so we're going to read through the Lab 1 sheet and look at some of the information on sheets uh, rows 1 to 22. So go to the lab 1 sheet, and we're going to talk a little bit about population, sample, parameters, and statistics, and then distinguish levels of measurement. So here on row 16, Dr. Hevy tells us this data set is fictional, so it's all fabricated data, and she says it's meant to simulate data from a statewide cardiac ICU hospital admissions in 2016. Since this is an entire statewide cross-section of information, it is a complete data set from the entire state population and would be very costly to assemble. Researchers don't have access to this amount of data except in rare circumstances. The U.S. Census might be an example where they get from a population. So if you scroll down on this data sheet here, it goes down really far. It's like 10,000, 10,000 observations. So if you were talking about a particular state, this would be the population, and we could like randomly take a sample from this to get fewer observations, and then that would be a sample. When we're talking about a population, each of these characteristics would be the parameters. So if we found the mean value for GFR, that would be a population parameter. Unless we had a sample, then we would have a sample statistic. So those are good concepts just from our reading to identify here in this data set. All right, let's see what else we should look at. All right, the analysis checklist, we're going to be building this out over the course of this semester, and the idea behind this checklist is to give you, to help you think about how to go through an analysis. So we've already read through some things in our textbook that are relevant to doing an analysis, but they're not really presented that way. And so I wanted to help you guys know how to walk through an analysis and how to connect these dots in a little different way than what they're presented in the textbook, because in the textbook it's kind of a collection of information, but we're going to really focus this down to, if we're doing an analysis, what should we be looking at? And so you'll see that this checklist has 3 main sections. Section number 1 is the study information, or I like to call it the big picture. What is this overall? Section number 2 is the data information, the data set information, and another word for this is data screening and data cleaning. So before you do any kind of analysis, you should be going through the data set itself to make sure that it looks okay and is ready to analyze. And then section number 3, if you're doing inferential tests, then you're going to have some information that you're going to look at for that test specifically, and you're going to do this kind of step 3 for each different test that you run. So sometimes in some studies you might be doing more than one test. Maybe you're doing correlations and t-tests or something like that. You're going to go through kind of some information. And so already from our reading, we have some things in each of these categories that we can look at. So what are the research questions for this study? And we haven't really talked about anything specific in the Hevy data set, but be aware, if you're going to analyze some data, you really should be tying this to what is your research question you're trying to answer, and have the investigators hypothesize any outcomes. So there's something that was in our reading, and just in an analysis checklist, this is where it would fall. So data set information, what are the variables in the data set and the level of measurement for each one? So this is something we can look at right now. So let's pull the Hevy data set back over and just take a peek at these. And I think I have a slide. Okay, I do. So, so our first variable is person, and you'll see it has all these different numbers. So, you know, you would think that, oh, this is numbers and they count up, and maybe this is ratio level of measurement. And that would be incorrect, because this is the only purpose of this is to give each observation a unique identifier. So it's really dividing people into groups, and they happen to be groups of one. So this is nominal level of measurement. When you have an ID variable, that's going to be nominal level of measurement. Even though these are numbers, because this just as easily could be, as we saw in the N-Haynes data set, where they had some combination of letters and numbers, in which case the numbers wouldn't mean anything. In this case, these don't really mean numbers. They're just a way to identify rows or individuals. So person is a nominal level of measurement. Date of admission, that's a date, and we'd probably call that interval level of measurement because it's just a calendar date. GFR is numbers with decimal points, and this is one of these situations where he didn't really give us a great code book. We're kind of relying on our domain knowledge, and luckily we're all nurses, so we probably could guess that this is glomerular filtration rate. And if you can say that 3 times fast, we're going to call that ratio level of measurement, because 0 could be our starting point, and these are definitely continuous data. Gender, and we have 0s and 1s, and again, we didn't get a good code book with this, so we don't really know what the codes are. This is one of the reasons why you'd have a code book, so I'm not exactly sure at this point, would 0s be females and 1s males, or the other way around, but this is categorical, so we're going to call that a nominal level of measurement. Height in inches, that's a physical measurement, that's going to be ratio. Weight in pounds, that's a physical measurement. 0 means 0, that's ratio. And CKD status, as these numbers get bigger, just from domain knowledge, we know that 1s are normal, they don't have a CKD problem, and 4s are the worst. And so these do go up in kind of an ascending order. There's order to these categories, and we're going to call that ordinal. So those are our variables in the data set and our level of measurement for each one. In an analysis, that's the first place you start. You need to go look and see what do those look like in your data set. So we're going to talk a little bit about lists and tables in Excel. Excel recognizes contiguous blocks of data where there are no empty rows or columns. So we're going to look at something just to show you guys that Excel can recognize these data. So here I've got these rows and columns in this data set, and if we already scrolled down, you know, to look at the number of rows, and we're looking at 10,000, so that's a lot. Excel can recognize that I have this set of data. So if you go to the Insert menu and click on Table, and we're just interested in looking at what did Excel identify here. I guess I should tell you guys, click somewhere inside of the data set. So I just did it without thinking about it because I do this all the time. You can click on the top row, or you can just click somewhere inside of this big block of data. And then when you go to Insert Table, notice that it gives us a range here from A1 to G10001. So Excel recognizes this big chunk of data as something that you're interested in. So that's one nice part of Excel, that it does recognize that. This data, this block of data, for Excel purposes is called a list. And Excel has a lot of functions for working with data in lists, which are pretty nice. So if you can arrange your data where it's got rows and columns, and they're all together, then Excel is going to recognize it. You'll notice that when we did this, it only recognized up to column G. I'm going to go ahead and click that one more time so you can see it. So it went from A1 to G10,000. So if there is a space or a gap in your rows or columns, so there is text over here starting in column J, but there's this gap of H and I with nothing in it, and so Excel does not recognize that or does not include this in the data set. And good thing. So when there's a gap, then Excel will not recognize it. So if you want something to be a data set, you can't have any gaps in the rows or the columns. So if we spent the time to scroll down through this and look carefully, we would notice that there weren't any rows that were totally empty. So that's an important thing to remember about an Excel data set and a data set in general. You can't have gaps in the rows or the columns. Okay, so so right now we're going to work on just recognizing. So right now this Excel chunk of data is a list, and we're going to go ahead and turn this into a table. And we're going to talk more later about what a table is and how we use it. But I just want you to be aware and try this out once so that you can see how a table, what Excel does when it creates a table. So we're going to go to table, and make sure that it has the checkbox checks for my table has headers, and click OK. And now you'll see that now we have this table. Everything's the same except it did change the formatting a little bit. This is cosmetic. I usually like to leave these just so that I know that this has been converted to a table. And you'll notice that Excel put in some little things here that we could use to sort some of these data. And if we sorted this like smallest to largest using the GFR, you'll notice that it actually changed the rows in the table. Didn't affect anything outside of that. We can go ahead and resort it back by the ID, the person variable, and get it back in the original order. So we're going to talk more later about some of the benefits of doing tables. You'll also notice that there's a name up here. You'll notice you get a new thing on the ribbon here under table design. If you click outside of the table, it disappears, so that ribbon goes away. But if you click inside the table somewhere, you get this new ribbon for table design, and this table has a name, and we'll talk about working with that later on. So if we were only working in Excel, that would be enough. We could analyze that table, and the other text on there wouldn't really matter too much. But if we want to work in another program like other statistical software, then we need to clean this up to be able to use it effectively there. So we're going to make sure you're on Lab 1 here, and we have our table, and we want to turn this into a data set that we could open in another program. So the first thing I'm going to do is create a copy of this page. So if you right click down at the bottom, hover over the tab for sheet 1 that says Lab 1. If you right click, you're going to get a menu, and we're going to select this move or copy. And we're going to click down here at the bottom where it says create a copy. And then we're going to go to book, and we actually want to make a new workbook. Okay, so we're clicked on create copy and new book. Whenever I analyze data, I will always save a copy and work in the copy. And that way, if you make a mistake, if something goes wrong, you can just close down the copy and you still have your original data. I never do something that's going to change my original data because if you make a mistake, you might have just deleted your data or corrupted it somehow. So I always work in a copy, and that's my recommendation to everybody as they're learning is make a copy. So we're going to do click create a copy and a new book, and then click OK. And now you'll notice that we have 2 workbooks open. I'm going to go ahead and close the Heavy workbook, and let's go ahead and go File, Save As, and put your name on it, you know, data copy or something like that, and hit save. Always good to save early. You don't want to do a lot of work and then not have it saved, or have your computer go down and lose it somehow. So okay, we have that. Okay, so now to make this for a data set that we can use, you'll notice we have spaces in these column names. And if you're making a data set, I recommend to never have blank spaces in the middle of the words in a column name. So person, that's okay, doesn't have any spaces. You can take out the extra words. I know what admission means. GFR looks good. Gender looks good. Height in inches. So this is one where it's useful. I like to use descriptive names, but can we do something to take spaces out? And we can. I'm just going to get rid of that big word inches and do an underscore character, which is shift and next to the 0 there, and then leave the in, and I can kind of figure out that's height inches. So something descriptive without spaces. You can either squish the words all together or do an underscore, and that works. Weight pounds, so I'm going to take away that and put an underscore, put LBS, and CKD status, I'm just going to add an underscore in between there. So I got rid of all the spaces. So many programs nowadays can handle spaces, but I would just recommend always get rid of spaces for variable names, and then you won't run into issues if you're using, or somebody needs to use a different program. So we need to get rid of the text on the sheet that is not part of the data list or table. So we have all this text over here on the side, and that's going to be a problem if we try to import this into another program. So I'm just going to select the column headers and go from I over to R, and then right click inside of there and go delete. And we just deleted all of that. This is where if you were accidentally selected the wrong column, you could delete a column. I don't know if Excel would, it did let us undo that, but sometimes if something's a complex operation, it won't let you undo it. Control Z will undo things, and so sometimes you can save something, but sometimes you can't. So we're going to get rid of that extra space, that extra text in there. Okay, we're going to save this. File save, if you didn't already, file save as, and give it a name. And this is going to be something that's going to be suitable to analyze later. Okay, so you want to go answer the assignment questions in Canvas and submit your new workbook with a single data sheet for this computer assignment. And that's it for this week's computer assignment. Post in the discussion board if you have questions, and we'll talk to you guys later.